everyone. I'm Jasmine with the Building Performance Institute. Thank you for joining us today to learn about energy efficiency and indoor air quality. This webinar is brought to you by BPI and the Learn program with two incredibly talented panelists, Jay and Joe. The Learn program offers free energy efficiency and electrification courses, and they have an extensive list, so definitely check them out at sandiegolearn.com. And with that, I'd like to introduce our panelists, Jay West and Joe Medosh. Joe and Jay, take it away.
Thank you. Thanks, Jasmine. If you guys have any questions, any comments, we do have the chat and the question and answer section open. But for today, we're going to do, and I'm ready to talk agenda if you're ready. Joe, do you want to say anything?
Oh, yeah, no, the only thing I would say is, questions, go in the question section, but let's get a chat going. Tell us who you are, where you're at, what's your weather, something. A really good webinar is when we have good chat in the background. So introduce yourselves in the background, please.
Yeah, if anybody wants to make any comments about my mustache or Joe's bald head, that's cool too. But I'm ready to give you the agenda. Thanks, Jasmine. So that's our welcome and our introductions. Then we're going to talk about what the problem is. Hey, Ben, what's happening? We're going to talk about what the problem is, and then we're going to talk about how to address that problem. So we're going to first thing first, we're going to talk about engaging the homeowner, asking questions, surveys. Joe's got a lot to say about that. We're going to talk about some examples of some visual inspection, some of the limitations of testing, and then we'll really get into a few things about particles, chemicals, specifically VOCs. We'll talk a little bit about radon, carbon dioxide, indoor temperature and relative humidity, and we'll do a little Q&A and wrap up. But before we get in that, does anybody want to add a
Joe? Yeah, I do. I'm going to add
ahead.
something.
So
we have 1 hour and probably even less because we do a Q&A at the end. So do not think of this as a complete thorough overview or a training or anything. This was just kind of, let's get the conversation going again. Here's some basic stuff. We're going to give you a wide range of overview. So this is not a detailed analysis of how to do step by step. So that's what your questions are for. That's what our discussion's about. But in general, this is not a training, and this is not an in-depth overview of some of these topics.
Yeah, thanks, Joe. So yeah, let's move on. Let's get into the problem. As we get into the problem, I do have a poll question that I'd love to ask. Thank you, Jasmine. What best describes your business or your reason for your interest in IAQ? Just choose the one that most describes your interest. Are you a program manager? Are you working as a contractor for a nonprofit or a utility-based program? Do you consider yourself a market rate contractor, or are you a homeowner or consumer? So I'm going to give you, I don't know, 10, 15, maybe 16 seconds to answer that. While we do that, let's talk about what the problem is and what we're going to address. And I know, Joe, you and I talked about that earlier. Joe, do you want to take a stab at that?
Yeah, I think one of the challenges or the problems, and there's your results as to we have a few homeowners here, but lots of market rate contractors and program managers and not-for-profits. So if you did not fit one of those categories, just throw it in the chat so we kind of can see who else is here that we didn't think about ahead of time. So I think one of the problems is that energy is trackable. We can actually track your energy bills and your usage in a variety of ways, but we really can't track the health outcomes that come with weatherization. It's a real challenge, and we've been trying to figure out how to do that and if it's even able to be done because of the things we have to do to get people to release medical records and tracking all that stuff. So we're going to kind of focus indirectly about there's an amazing amount of benefits from energy efficiency. And that's really the indirect path here. So the problem is that when you're doing your assessments right now, are you aware of the actual health benefits of some of these standard stuff we do? So we're going to kind of wrap all that into our discussion today.
Yeah, thanks, Joe. I think we're going to talk a little bit about, the fact that 90% of our time we spend indoors. By the way, we live to be 79 years old. That means we spend 69 years of our life indoors. And according to the EPA, the air inside is 2 to 5 times worse than outside. And we know that energy efficient homes are tighter. So one of the things that we're going to try and do on this webinar is give you an idea of maybe some ideas about how a process that you might use while you're in the home. Maybe some different ideas for especially some of those program managers out there about how you can address and institute indoor air quality and healthy housing into your program, inside or in addition to the BPI healthy housing certification. So let's get into the next part, and I think Joe's going to take it from here.
So this is a slide that Kevin Kenny and I came up with years ago, and there's a lot of healthy housing challenges or conditions that are in the house. And what's great is that that's what weatherization does. You do well at finding these. Some of these are safety issues. Some of these are actually indoor air challenges. These are moisture issues. These are a variety of challenges with the HVAC system. And then here's what you're actually doing. Here's the people that are in the house, and you're actually measuring these conditions. Next slide. So you can actually see that you're doing these visual assessments. You are measuring for moisture more than you ever have in the past. You're measuring exhaust fans and figuring out carbon dioxide and for some people and carbon monoxide issues. That's a major safety outcome. So all these things are actually being wrapped around into a much higher level in weatherization. So we want to kind of highlight that. Although you're there for energy efficiency, if you really look at the outcomes here, these are a lot of healthy housing improvements and diagnostics and communication that you're doing for these occupants. This is a slide that I created years ago because they say that EPA is safely says that your indoor air is 2 to 5 times. I think it's more like it could be anywhere from 10 to 35 times worse than outside. It's way worse, and because
That's a lot.
it is because
Yeah.
because you're well, you're measuring, and it's really outdoor can be not bad, so indoor it's going to be way worse. So if your outside is really bad, then maybe you do good 2 to 5 times. But in general, that the occupants and all the things we're doing in the house and things we have in our homes are really some of the worst conditions that we keep putting on ourselves. So, we just look at some of the stuff that's in here, from carbon dioxide, and the amount of skin cells we shed are millions every second. And then you may want to vacuum and you actually stir up dust for days. So your moisture issue, the actual occupants are worse things. And one of the things we're identifying more is that the amount of pollutants that are inside are because people have their own cleaning materials and they're not really storing them correctly. So we are actually, us as the occupant are the real challenge. So you can't just say it's a generic thing, but if you really analyze how people are using their house, you may find out that some are really doing well and others really need to have some education. I think homeowner education is a fundamental element here that we don't have direct slides on, but I know your programs have a lot of great handouts on these.
Yeah, and that brings us to customer education, or engagement. It really is just another type of engagement. We want to ask questions. We want to make sure that we're sharing information with them, and we want to make sure that we're keeping them involved. Because I think Joe would like to take it from here for this next slide, but he's going to explain to you why it's so important to engage that homeowner.
Yeah, because they know more about their house than you do. So that's sort of the reality. It's if you want to find out what's going on, they can tell you where their problem areas are, or what kind of issues they're having, or why they think their bills are high, or all that stuff. They know more about their house than you ever will. So you need to make sure you're giving them the chance to voice up and explain what are the real issues in their house. And we want to change some of your dialogues. It's kind of common. Is there a place where you're uncomfortable? Because uncomfortable used to think about as your temperature wise, but now it could be that I have a hard time breathing in my kid's bedroom, or other conditions. So it's a holistic approach to that concept. The one tool that we will stress today is that you are the greatest asset of actually being able to confirm the diagnostics in a home, because your brain's going to give you a lot of information, especially the kind of training you have, and you're going to be able to use that to communicate to the occupants. All right, and then people think, oh yeah, it's all about a visual assessment, but that is key to trying to observe some of the conditions in the house. Suddenly you see a lot of candles in the house, or you see how they're living. All this stuff gets wrapped into maybe your testing and your monitoring as to I understand what I'm able to observe in the house visually. But the one place where we actually find that we're actually doing a whole nother level of diagnostics is our olfactory. So when you're dealing with what you're smelling in the house, is the first time you go into the house, you may smell, oh, I think they have cats, or there's some serious challenges with ventilation in this house, because you can actually literally smell it. The challenge with your olfactory compared to your be able to smell compared to seeing or what you breathe in, whatever, is that your nose can shut itself off after a few minutes. So if there's a really bad smell, within about 10, 15, 20 minutes, you won't really smell that as much anymore. It kind of dissipates. So people that are living in a home where you're like, wow, this smells awful, to them, they can't smell it anymore. So you got to remember that those odors are new to you. So your first few minutes in a house are crucial as to what you're observing, what you're smelling, and even more about what you're inhaling or what you're breathing. It's all part of what you have. So I could probably tell if a house has high humidity, next slide, because of what I'm actually breathing. So that's really something that's happening. I'm like, wow, hard time breathing in here. Maybe it's high particulates. Maybe it's a variety of stuff they're using to overcome other smells that they have in their house. So all of these things are also what you're doing to communicate to your clients. I'm breathing, I'm talking. All together, you got to trust your gut and realize that you are the greatest tool that you're able to have. You're the greatest diagnostic opportunity, especially when you first go into the house. And as you keep moving through other rooms, you're going to find out that, wait a minute, there's something here that I need to pursue or trying to figure out what's causing this, or we're going to realize maybe I should do some testing in this area. So this is kind of just a placeholder for diagnostics. I'm going to step through some of the basic diagnostics that many of you are already doing. So you are already doing a lot of healthy housing measurements. Some of these you may or may not have. So we do have a poll here. It's like, do you have a moisture meter? So it's a yes or no question. And I guess the question is, are you also using it? So I'm sure if you had it, you'd want to use it. And there are two different types. There's refer to them as direct and indirect. So I can actually probe it, or I can use an indirect where I don't have to do any invasive measurements. But in general, do you actually have a moisture meter? Is one of the questions here. There are some other tools here that you see that are, IR measuring temperature, and about half of you, a little more than half of you do, so that's great. Some of these are really not that expensive for a moisture meter. You should really think about something you should have. Use them wisely for all these tools. Not everything is immediate diagnostics. And as you move over to the right, now we're actually measuring carbon things in the furnace. You actually should always have your ambient CO detector with you. And there's some that are combination tools that can do a lot of this. So many of these tools you may have, or you may want to think about this as an investment for myself, or maybe your program wants to do some of these things. You're welcome to reach out to us anytime to talk about some tools that we think your program would benefit from. So we do have one more survey. Is that who here has an IR camera? So infrared has now become something that's common. When Jay and I first met and got in the industry, these were like very expensive, very rare. Hardly anybody had one of these things. Many of you are measuring exhaust fans and a variety of things, whether they're using a flow hood or the indirect red or black boxes, as I'll just call them generically. And you're doing duct diagnostics in terms of leakage with ducts, which are huge. These are all contaminant pathways or exposure pathways in the house. So your blower door is huge. So yes, great. A lot of IR cameras. That's great. They've come down in price significantly. You can add them to your existing phone and do a lot of stuff with them. So combined with the blower door, that is a high level diagnostic. So I can actually determine where I'm missing insulation or where I actually have infiltration that's not really related to missing insulation. So these are the kind of tools you should realize that they're not just giving me energy loss, but they're also giving me exposures to my occupants about conditions in the crawl space or an attic or other stuff.
Yeah, I was going to ask that too, Joe, if you could just emphasize that, but thanks for clarifying.
Sure, right.
Yeah.
So I have dozens and dozens of these types of devices in my house. I don't use them all the time. I have a few that I have that kind of run just to make sure if one of them goes red, they all should go red, that kind of thing. But in general, these are not incredibly accurate, and they are not intended to be incredibly accurate. These are not the high-level measurement devices like you have for doing pressure on a blower door. These are actually a snapshot in time. They're really a trend indicator. So whether or not you're accurate on my particulates, it doesn't really matter as well as the particulates are trending up or down. So I don't use this device to tell me how many particulates it's measuring. It's like, holy cow, my particulate level went up. And they're only measuring in that specific location. So they're very limiting, but they're also very valuable. If you use these well, they can give you a great snapshot as to what's happening to this home, where it's at that time.
Joe, do you live in Hong Kong?
Not anymore, but I will say that, what, we are all lucky to be in America because our AIQ, which is your outdoor air quality, and the conditions that we live in and don't need to have a mask to go out to the grocery store. Those are things that other people in the rest of the world many times have. So we're pretty blessed with that. So this is kind of a quick visual to illustrate. If you had an IAQ monitor, think of it as the bulb. So right now I'm measuring my office, and that's all I can really measure. It's not going to measure other areas. So if I were to move around the house, you can see that, okay, I'm measuring the kitchen. And by the way, the kitchen is a toxic environment. Your numbers are going to be off the chart. You're going to have high particulates, carbon dioxide, monoxide, a variety of stuff that's given off. So don't think of your kitchen as a representative of the rest of the house. So use it cautiously and in reference to really what's going on. And as I keep moving around the bathroom, I'm going to probably get high humidity here or other challenges. So these are places where I would want to monitor for a while. If I left one at a house, I'd want to make sure I had them move it around. And then as I kept moving, maybe the living area downstairs. Next slide. Okay. And then also the bedroom. The bedroom is one place that I always would include monitoring the conditions. So I'd want to compare. They're spending 8 hours, sometimes at least 6 hours, maybe more in the bedroom. So it's a great place to be monitoring and measuring. And then I would compare that to other parts of the house. So that's the concept. Yeah.
Joe, real quick, I want to just add to, one of the ways that I try and explain to homeowners or consumers about, your point about how um, indoor air quality, how pollutants act. I talk to them like, imagine if there was a cloud. And oftentimes these clouds dissipate the further you get away from it. So at Air Advice, when I'm talking to contractors about testing, we say don't test in the kitchen because you could have a monitor right next to the kitchen sink. That thing's running for 5 or 10 minutes for maybe defrosting a chicken, breast or something. There's a cloud of humidity that's engulfing that meter, and that meter thinks the entire house, or the person who's interpreting the results thinks the entire house is in that cloud. So I just kind of wanted to add that.
Yeah.
Yeah.
So yes, well done, Jay. Those are great. So again, back to using your brain as to what you're
Mhm.
observing, where you're going to place your monitors. I look. You don't want it next to the cat box. Some basic stuff in the house. That's right. Right. But many people, when I talk to, they think that their IAQ monitor that sits in their living room or maybe in their bedroom is giving them an entire analysis again about the home and it's telling them everything they would need to know. So I want to stress here that it's not a blood test. That chart on the left with the orange is a blood test, and that tells you a whole lot about your blood and what you've been eating for months or days or right now what's going on with your blood as well as a history. These IAQ devices do not do that. They have a large range of what they're actually measuring. So I just want to make sure people use them with your brain because they're just giving you some basic information that I can use to support my visual observation. That's really what you're doing. All of these diagnostic tools are confirming what I'm observing and what are the conditions. Now let's take some measurements and let's monitor some conditions and confirm that I saw this. Wow, it seemed like it was high humidity in the house. That just must have been that day. We monitored for a week afterwards and found out that most of their humidity levels were around 45 to 50. Those are great numbers. Or my VOCs were actually fairly low. We'll talk about VOCs and some of the other ones in a minute because those are really challenging things to either monitor or measure. So.
So yeah, so let's talk a little bit about actually testing. So again, in the broader context, what Joe did a very good job of summarizing, and that I want to again open up the context to, is as a process of someone who is on the front line, who's in the field, who's in the house. All those things that Joe talked about: looking, asking, smelling, thinking, and getting an idea of what the context is super important. If we decide that we want to test, maybe we want to test for, and these are some of the examples that we're going to give. This isn't the only things that that you're going to want to test for, but maybe these are some of the larger parameters, types of pollutants that you want to test for. They include particles, chemicals, specifically VOCs. Now, there are thousands of different types of VOCs. So for our conversation today, I'm probably going to talk just about TVOCs and let the questions fly. I want to know, I want to hear about your issues with testing for TVOCs. I've got an answer. We're going to talk about carbon dioxide, radon, one of the scariest words of all of the indoor air quality words. And then we'll talk a little bit about indoor temperature and relative humidity. Um, and I'm ready when you are.
So we didn't do this as a poll, but since you guys are all listening and the chat's going great, everybody, thanks for the. So who here is an HHE? Chime in. I'm an HHE, and how long have you been doing that? Who here has done the HHP, Healthy Housing Principles? That's a self-acknowledged test, and it got a great reference guide. So who here has dug into some of the healthiest stuff? We want to hear who you are and how
Nice.
long you've been doing that. So yeah,
Yes. Awesome.
yeah. What, John, why don't you stay with particles, and I'll come back towards the end here.
Okay. Sounds good. So particles. Let's talk about particles. So next slide, please. So the most important thing to understand is the particles that we are talking about are much smaller than the human eye can see, much smaller. 50 microns is the limit of what a human eye can see. What we want to test for is PM10, PM2.5, PM1. So we're looking at about, say, 90% smaller than the finest grain of sand. And so in the next slide, I'll explain why. So there are many potential causes for these types of fine particles. Could be combustion. It could be animal dander. It could be smoking, activities, any number of things. I think, Joe, did you want to reflect on anything in here?
No, the only thing that I could highlight here is there's one thing that stands out more than the others. Candles are an issue, combustion appliances, and cats, whatever. But smoking is just on a whole nother level. And that it's just something that if your homeowners are smoking and they're complaining about particulates, then you need to kind of remind them that one of the things they're doing, they're actually making it much worse, because not only is clearly smoking worse than anything, but they're also taking it in as they're smoking. Smoking is like, it makes radon worse, makes everything worse,
Right.
because as you're smoking, you're also inhaling all the other issues that are around you. So definitely
But that's
something
only
to look at.
cigarettes, right? That's only,
It doesn't matter what you smoke or where you smoke it. It's you're
uh,
actually taking something and putting it into your lungs. So yeah.
but vaping's fine, right?
Yeah, nice lead up, Jay. No, it's not. All those things are actually causing issues, and there's a whole great studies about what's really in a vape and all that kind of stuff. It isn't just a moisture issue. So all those
No.
things are actually increasing other particulates coming into your lungs. And the one thing that is here, there's just not only so much you can put into the slides, is that the amount of dust that's in a house is just incredible. And if you really want to, one other sampling technique is to sample dust, because it'll tell you everything about your house and the history. So a lot of these things are professional based and consumer based.
Yeah, thanks. All right. So PM10, PM2.5, or PM1, PM01, they're known as coarse, fine, and ultrafine, which, by the way, if you look up Joe Medosh on the internet, you'll hear many of those words used to describe him, specifically ultrafine. But let's talk about how they affect into our. I'm kidding you. I'm not kidding you. The PM10 is usually going to be from natural causes. So pollen, maybe some wood burning, dust, traffic, pet dander. Those are the type of things that we're going to see. So the issue with these super small particles, these particular coarse, fine, or ultrafine particles, is that they get past your natural defense systems. So what you see in this schematic is sort of a overall idea of how deep each one of these categories of particles penetrates the body. PM10, not as far. PM2.5, PM1 from exhaust, biomass, cooking, bacteria, fungus, even some viruses are about that big. It's kind of big for a virus. They're going to get even further into the body. And then when you get into the ultrafine particles, they get past your body's defense systems and can get deep into tissues, including your brain. Joe, is there anything that you wanted to add about that?
No, the only one I'll tell you is that the PM point one is actually the kind of exposure you get when you're sitting in traffic. That's the kind of fine particles you're getting from automobiles and other stuff. So you can
Okay.
just see that. So think about that. That was one of the things that we used to have some haunting stuff that we do to you. So next time you're sitting in traffic and you imagine this illustration as to how far the smoke that's in front of you from the previous car is getting into your body, you'll realize why it's important to recirculate the air and think about a better filtration system for your car. So there you go.
Yep. All right. Next slide.
So one of the things that it came to me a while ago that we've been using the blower door for energy analysis is probably as long as the blower door has been out there, but it came to me and I realized that, wait a minute, this is actually an exposure pathway or a contaminant pathway measurement device. This is actually a device that isn't just telling me how much infiltration I have, but also giving me exposures to what's outside, what's in the crawl space, what's in the attic. And an analysis of actually saying, okay, I can now determine that I have duct leakage, or I just have connections to the attic, or again, the garage, all the places that are not part of the normal indoor environment, which may have its own conditions. Think about what this blower door is really giving you in terms of a great insight as to where these people may have exposures. If they're storing all of their paints and chemicals in the crawl space, and you find out that it's heavily connected to the indoor pressure boundary, holy cow, we now know we need to get that stuff out of your crawl space. That crawl space or your garage may be heavily connected. This is the next level of analysis that the blower door is going to do for you. These are all particle devices. All of these will do measurements, and they can also be set up to do monitoring. They range in price from probably a couple $100s to several $1,000s to being a service that you can actually work out with Air Advice. So all of them are doing a variety of measurements for particulates, and they're giving you a variety of reports. And this comes down to is what is it you need to measure and why, and what are you going to get out of the device? What do you need to get from your device, and what does it provide for you in terms of that? All of these, except for the Air Advice, are going to be blunt. So I don't work for Air Advice, but I can tell you why I think that it has a benefit, and that is all of them give me a bunch of numbers, and I need to figure out are those numbers kind of good or bad. The one thing that Air Advice is trying to help you is here, contractor person. I'm going to help you with some checks and balances that these numbers are basically high with a red, yellow, green report. These other three aren't giving me reports. So if you're really looking for something, you need to figure out how do I get my Dylos or my Particles Plus devices or that X-Tech, how do I extrapolate that stuff? So whatever you're going to get, there's a variety of stuff out there. This is a tiny little sample. When you get your measurements, how do I know what they mean and how do I provide that to the client? That's the key part. I can't just tell them some numbers or take a screenshot of my device. None of that makes sense. What are you explaining to your client at the end?
Joe, one more thing. Do you want to differentiate between testing and monitoring?
Yeah, that's a great thing. So testing is clearly what I'm doing right now. It doesn't mean you're going to get your exact results right now because I may do a sample. A sample is testing. So I may sample conditions in the house, and especially for VOCs. It's really, to me, I'm not a firm believer of doing live monitoring or live measurements for VOCs. I think sometimes that's something you really need to do as a controlled process and send it back to a lab. But one is actually right now I'm testing, right? So I'm testing humidity in the air right now. What's my RH versus maybe doing a long-term analysis. So that's your monitoring versus actually a quick measurement. So immediate versus actually a long-term exposure in that area at that time.
Yeah.
Yeah.
So what do we do about it when we get those results? Well, let's talk about it. First, let's talk about source control. So before we do anything, now Joe just talked about closing those exposure pathways, sealing the shell, insulating. So this is, that's always the place that we want to start. But we want to make sure that we're also controlling the source. So with particles, one of the main sources of indoor air particles absolutely is cooking. You'll see this time and time again. If you're monitoring, you're going to see grave spikes that take a long time to come down. So, you know, one of the main things that we can do about limiting particles is either have electrify, especially cooktops, but also any sort of combustion that you might have internally. Turning that over internally, meaning in the house. And all that stuff, if you want to know more, let's talk about healthy housing principles. Keep it clean, keep it pest free, keep it dry, keep it contaminant free, and keep it ventilated. And let's keep it rolling.
There was one question that came out in the chat. I think it's worth mentioning right now. So Marjorie said, she goes, yeah, I have all these STS sheets and all this stuff about some of these products, but just so you know, STS sheets are only about the person installing the product. They're not about the occupant exposure. There's other sources for that. Health disclosure declarations and a variety of stuff you kind of do more digging into. They may have provided that, but in general, those are only about you, the installer. So yeah, go ahead, Jay.
Yeah, no problem. So the next thing we want to know, again, now that we've already talked about, now that we've already addressed the shell, we're kind of actually focusing more on mechanicals. And you're going to find that a lot of the things that Joe and I talk about going forward, what do we do with these measurements, is going to have to do with mechanicals. And of course, when we're talking about a forced air furnace, we're talking about the air handling system. So we want to make sure that that air handling system is clean. Oftentimes, as you all know, that ductwork was never designed correctly and it's not doing its job. So we might need to install or upgrade the ductwork itself. The variable speed fan is going to come in crucial because there are times when we're going to need it to run harder to move more air than others. And of course, those controls, the upgrading, the controls, that might not just mean a thermostat. There are plenty of control systems that react to the indoor air quality environment. But these are just some of the things that we want to talk about, and we're going to bring back every time, every single parameter and pollutant that we talk about, we're going to come back to air handling and optimization. So let's move on to the next part. So
So,
cleaning the air, hey, with particles, it's fairly simple. As once we've taken care of our source control, if we're doing some spot ventilation for some of this stuff, then the next step is simple filtration. We want to clean, replace, and upgrade that filtration system. There are so many specifics. There's so much to know and understand. Once you've tested a house and you've got a good idea of, hey, which particles are PM10, which ones are 2.5, which ones are 0.01, now you really understand the importance of a MERV rating or a HEPA rating. And again, we don't have time to dive into that today, but that is very, very important when we're talking about cleaning the air.
wait. So I got to go back one for me. So 1 second. So the one thing I do want to stress is that your best approach is always filter, 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 capture it, throw it away, replace it, filter, filter, filter. Anything that you consider to be adding. I'm adding this stuff to the air to make it
Additive, yeah.
heavier or electronic or whatever. You're also adding something that your clients are breathing. Be cautious about anything that's considered an additive approach versus just taking stuff out. You want to take stuff out of the air. You don't want to add stuff to the air. So it's a real, fuzzy place to go. It's pretty clear message that I'm trying to give you is that you are only going to be removing stuff from the air. Do not think as a program that you're going to add stuff to the air that will improve that. You're only actually making it worse.
Good point.
So these are some of the action levels. I'm not going to read them all. You can see what they are. You're welcome to do a screenshot. That's what I would be doing right now. And these are general action levels. So as many of your devices are going to give you something that's very similar, but you can see that clearly lower levels are always common. There's always some particles happening. There's a certain point where it gets much higher, and now we need to be more active. So if your system has filter bypass, like we talked about the filter, but you need to make sure stuff's not going around the filter. So you need to make sure the filter is well sealed in that, or tape it into place, or you're going to add additional standalone filtration. So those are some of your recommendations.
Yeah, I just want to say real quick about those, and we're going to thank you. We're going to come back. We're going to talk about these recommendations. These recommendations were actually put together by Air Advice for Homes. That's where they came from. However, the source, the actual for the particles are the EPA. We use the EPA, California Air Resource Board, and the International Well Building Institute. That's the source of this particular general action level for particles. Thanks, Joe.
Thanks.
All right.
VOCs and chemicals. Yeah, let's move on. Right. So there's more probably VOCs and particles and other stuff than maybe there are by 10 numbers of people on the call. So it's just a huge amount. And we usually are, as Jay mentioned, we're talking about the total VOCs because it's really not possible for general stuff to do is to measure a single VOC particle. So, and these are your volatile organic compounds. They're vaporizing at room temperatures. There's a lot of carbon atoms, multiple ingredients that all go together here. So in general, you get one or two of these together, they're actually making a new VOC. Put sunshine on them, you're going to get another VOC. So they're constantly fluctuating as to what those are. So VOCs can be something that actually the homeowner is actually making themselves or their building materials. So let's move on to some of your options that are here. So new homes or upgraded homes can have a lot of VOC sources. Those are the finishes on some of these materials or the appliances. When I worked at a previous company, we recommended you took your appliances out to the garage for a couple of weeks sometimes, try and let them run, get them to off gas. So new things are just bombarded with these chemicals. All of these cleaning sources that you're doing, these are all really VOCs. The general generic, if you can smell it, it's a VOC. So not all VOCs are bad. Let's make sure we clarify. VOC is not a bad thing. It just means that you have an odor and it's off gassing and something I probably could measure. But if you look at some of the stuff underneath this person's sink, clearly there's much cheaper, better ways to actually do cleaning products. I know that's one of the things that many of these programs are giving them is, hey, vinegar water and a variety of other options can actually reduce this expense and make them much healthier. And
Yeah.
the one that always shocks me, Jay, is when people have all of these things that they have in the house to hide their other odors. They got incense and these
Yeah.
plugins and all this stuff. And I'm like, you are now actually making more VOCs and you're actually causing some of your other VOCs to actually maybe even be worse. So as soon as you come in, you're like, oh, wow, this house smells fresh. No, it smells like a bunch of chemicals.
Yeah. Very
So
quick comment too about the VOC thing. Joe is absolutely right. You opening up a glass of wine can produce VOCs. This is one of the reasons why if we see things in the house that have VOCs, like the things we're looking at right now, we might want to test because the level of VOC really is the problem. And I cannot stress that enough. Certain VOCs are completely fine at certain levels, but at high levels they are not. So that brings us back to the testing thing, and I'll give it back to Joe.
okay. So these are one of the most challenging things to measure in a house and actually kind of identify. And there's a variety of solutions, which I believe comes up a way to test and what do you do. So, but eye irritation, headaches, all these things are common issues that people have with VOCs, and they really have a hard time identifying that it's actually in the house. The one thing I remind you as the person who goes to the house is that if you're measuring VOCs, make sure you're not what shows up on the test. Your cologne or your perfume not only show up on these tests, but they also can irritate your client. So if somebody is hypersensitive, many people talked about that, or chemical sensitive, and you got your, super duper new cologne you got for Christmas, those people are going to ask you to leave because they're used to saying, wait, you're actually causing me a headache. So try and stay odor VOC neutral when you go to a house or go to some of these things. It's a indirect challenge that people have and don't realize it until somebody reminds them that I can smell you, which is you may smell great, but they don't want to smell you. These are some of the ways you guys can test VOCs. One of which is actually on the air device, you're actually able to monitor it. I would encourage you to leave it longer. I would think that I would try and figure out where my VOC highest level is. I always try and monitor where they live, which is a bedroom. That actually could be high VOCs because they maybe have a lot of chemicals or beauty elements that are in their bathroom, which are VOCs. Their living room is the next place that I'd always want to do because that's a very neutral place where I might be able to get that. So and you don't really want to put it against the wall or over on some table that's in the middle of nowhere. You want to try and get it somewhere where there's a good air movement, and I'm measuring that house. The other one here is home air check. This is one of the most powerful tests you can do. And again, you may do one in a house in a central location and find out that while those VOCs were high, they actually give you an amazing analysis of what they think the VOCs are from. They've got an amazing library of telling you these things are commonly from these certain things. So the goal here would be to do those in multiple locations as a follow-up test to determine that we think your bedroom or this living room or this new office you've got are your potential risk.
So what do we do about it? We test. How do we react to our assess? So first of all, source control. And like Joe just said, so much of this with VOCs we can do by just simply buying low VOC products or not bringing them into the house. So reducing the use of incense and candles, not just a source of particles, but also a source of VOCs. Store chemicals outside or in the garage seems so easy, but so few people do it. Reduce the use of treated pans for cooking. Hey, I know this sounds crazy. I work for Airvice. I see a lot of reports. You would be shocked to see how VOCs go up in a building when you're cooking with a treated pan. Surprising and shocking. And just if you're doing a retrofit in a house, if you can use low VOC materials, I know that, and I'm talking about plywood, talking about glue, paints, any kind of glues that you can use that are low VOC, which I know they're more expensive, makes a huge impact. Next slide. Clean in there. Joe, did you want to, you looked excited when this slide came up. Do you want to say something about it? Do you want to take the slide?
Yeah, I am. I can't wait. Okay. So, stuff as simple as opening your windows is a huge thing. Cracking your windows, even a little bit on both sides of your house, will give you some natural ventilation, right? Activated charcoal filtration doesn't last long, but it is an additive, or do a standalone. There's a lot of great standalone options now for activated charcoal, whether it's just sits there in the room and absorbs stuff or not. You put it outside and it recharges. Or where we're really headed is that you're dealing with a balanced ventilation system. You still may keep your spot ventilation for moisture in your bathrooms, but in general, we're now trying to figure out how do I bring air in, mix it with existing air, so I'm tempering it, and I'm constantly on a low level replacing the indoor air. So if you really want to bring in this outdoor air because it's really never fresh, then an ERV is definitely something you want to be looking into.
Yeah.
So your visual observations here are going to be huge. So whether you take off this register and look inside, you probably can tell that the register is dirty already. There's a variety of things you can do to give your nice visual assessment of that. So installing the fan, we've already mentioned that before. Upgrading controls, whether you need to add another system or not. So there's a lot of things, if you haven't caught on yet, that the heating and cooling system, which may or may not have ventilation, is something that's going to make a major play on how you actually deal with indoor air quality.
All
These
right.
are,
So
go ahead, Jay.
yeah, no, so I want to take this one because this is another really good example of why you would want to test. So we know that we need to ventilate right because we air seal tight. However, how do we know if an activated charcoal filter is going to be good enough? Or if it's not going to get the results for our customers that they need? This is when testing does come in handy. So again, as Joe said, these are general action levels. They're not hard and fast. They're taken from this one also taken from the EPA, HealthLink BC, Minnesota Department of Health, the Endocrine Organization, American Lung Association. However, the point is this gives you a nice idea of, hey, if you're below 300, you're okay. Nothing to worry about. If you're 300 to 500, these are micrograms per cubic meter, you might be okay with an activated charcoal filter and a freestanding one at that. However, now when you're between 500 to 2000 micrograms per cubic meter, an activated charcoal filter may not do it. You're going to need ventilation, and you definitely need to make sure that your ducts are sealed and that you have controls that call for air movement regardless of a call for cooling or heating. And if it's above 2000, then I don't think you're going to be able to handle VOCs that high, regardless of their source, unless you have an actual ERV or HRV and their ducts are sealed tight and you have controls that work that. So I just had to jump in. I get super pumped about it. I'm going to dream about
Okay.
it. Next slide.
All right, we got to keep moving. So,
Yeah.
carbon dioxide, the AirNet is one of the best devices you could use to measure that. And there's a variety of sources. Usually, it's those things that breathe in your house, which means you or animals. In general, two animals creates an adult. So keep moving. So those are the kind of things that you're trying to keep track of. So, Jay, go ahead. We got to make it quick.
Yeah. So yeah, thank you. So the big thing, what I want to show you right here is the test results that were done. I think this was a Harvard test, and I think it's really important to understand like what carbon dioxide does, high levels of it. And some people say that high levels of carbon dioxide is a proxy for low levels of oxygen, but the effect that it has is almost directly observable in our brain. So what we're looking at here, those white pulsating dots, that's where people were testing at 600 ppm of CO. So the next slide, please. Now when the CO2, sorry, I said CO, I meant CO2. CO2 goes up to 2,500. Look at how this affects our brain. So if you look all the way to the left, basic activities, now we're marginal. We went from superior to marginal. If you go to the middle, our initiative is dysfunctional. Our information usage, the breadth of approach, and our basic strategies are all dysfunctional at high levels of carbon dioxide. So that's all I wanted to say, Joe. I'll give it back to you.
So this is a quick slide that it's reminding you you can't hold your device to measure carbon dioxide throughout the house. You're only measuring yourself and what you're breathing. So this is something that needs to be left somewhere and then walk up to it and see what the numbers are. But in general, this is not a handheld device that you walk around because it's just you that you measure.
So what do you do about it? Source
So
control. Yep,
yeah,
go
we've
ahead,
been
Joe.
there. That's right. Yeah, I
Yep,
mean, so it's all about replacing standing, get rid of these atmospheric things. I know that's a common thing for all weather stations are doing, and get rid of your kids because they're breathing too much. So there you
that's
go.
right.
Yeah.
Yep.
But don't get rid of your animals. You're right. Okay. Wait,
Source.
we've been here before. That's right.
Yep.
Optimize your air handler system. So, right now, if you're replacing a system, it's going to come with a variable speed motor already. You can no longer get a PSC motor. So, all those are basic stuff. You can swap out the motor. They do that a lot with Rockus as one of their things. So, again, these are similar stuff we're saying. So, if you haven't caught on, upgrade your HVAC system to handle, regular air movement for filtration and other conditions you're trying to control.
Yeah, and if I may, there's ironically there is no really good single standard for carbon dioxide. So once again, this is taken from the EPA, from the California Air Resource Board, and the well building standard. But as you can see, different levels of that you might test for, that you might measure, might mean different interventions and different measures. So let's move on.
Radon, here's a popular word for everybody. So here, the variety of sources are, it's just what comes out of the ground over a long-term source of actually, millions of years, and elements are decaying and decaying and decaying. And at one point, it's crazy that they become actually a vapor and then they go back to being a solid. If you really want to see how things actually change throughout a long terms in time, but there's a small amount of time, just a few days, where radon becomes a vapor, and now it's coming up through the ground and actually entering your house, and you enter your lungs, and it decays one more time in your lungs. Those are the things that actually causing the radon issues that we think about as radon as a problem. So it's a short window over millions of years of decaying granite that actually it happens, but it is something we can measure and take action levels on and be very preventative as to how to reduce it in a home that measures high. It's shocking the amount of people that are actually able to. This is an indirect path we actually can conclude. Like, okay, we know how many smoking deaths there are. We have other deaths. So it's an indirect conclusion that we're able to make on a variety of stuff about how many people are probably dying from radon. It's a statistic that's overseen by many people. So it's been well established. People aren't really arguing this concept, but if it's a long-term play. It's not like I'm exposed to radon for a couple of days or a couple of months that it's happened. This is a long-term exposure, and we're able to conclude that there's nothing else that could have caused their lung cancer.
Yeah, I
There's
just
a
want to say
yeah.
monitoring is the answer, right, Joe? And this is an Air Things monitor. Neither one of us work for them. We don't get any money for them. I have one in my house, and I live in the Midwest, and I can tell you that in the wintertime when the ground is frozen, in the springtime when the ground is saturated, I have 0 picocuries per liter. In the summertime, as it dries out, I'll get up as high as 8, which is terrible. So the point is, I personally highly advocate for monitoring radon.
Yeah, you can test for it, but it is mostly you're trying to. But let's stress that if you're going to monitor it, then there is one that does for dealing with real estate, which is a 24-hour test with closed house conditions. But if you really want to know what's going on in a house, because that's actually decide because you have such a short amount of time, you need to be doing the EPA recommended 6 months long-term test. It's not a closed house condition. So if you really want to know, do
Yeah,
the 6 months test. Okay.
right.
So now these action levels are based on EPA, but most of these action levels are now kind of also guided by your state. Your state now oversees that you have to be a certified tester or mediator, or any of that stuff is now a state level condition. So check in with your own state as to what they're telling you. The action levels are probably very similar, but in general, if you're going to test or do something, you now actually probably need to have a certification based upon where you live. So this is something that's built into BPI and who we are and how we live and what we measure and what we do. So let's dig into these issues. And these are probably the most, of all the stuff here, this is probably the most common issue that we're having. All right. So a variety of sources that are in here, from showering and people pets, things that people are using in their home that are producing these, the amount of showering, or the one thing I can tell you, if you're using your dishwasher, do not do the fast dry. Those are also really chemicals. So think about what it is that's causing the moisture, how people live. If I had a house of 3 people, I would want to ask them, like, I'm assuming that, and make it in a positive, I'm assuming everybody takes a shower. About how long are you showering? Those are kind of things that give me diagnostics or just general information about, interesting. So if you're all taking an hour shower once a day, that's a lot of humidity. Now, this has been an established level of, like, if you have too much or too little humidity, these are the potential conditions. I actually like a one that actually goes 35 to 55, but in general, you see this a lot, that below 40 is considered dry. And that means that your lungs are a little more exposed to actually, viruses or other stuff. It's super dry. I know many of you, like I live in a dry climate. I've lived in Arizona. I live in Colorado now. And people aren't like all sick because it's a dry climate. So it's also what you do is you change. If you go on vacation somewhere and it's high humidity or low humidity, you may find you understand this impact. But in general, higher humidity is going to give me more conditions that are actually prone for, a variety of stuff from, you can see on there, the dust mites, the fungi, the viruses, all those are there. I learned this the hard way, and that is that you do not measure humidity by taking one test in a house in one location. You really should be mapping the humidity, and you don't just map it by one test in the room. So right here, I'm showing you that if you're near the air conditioning over on the left side, my humidity changed from the middle of the room to the far side where it's much warmer. So you really need to be doing a couple of tests throughout the house or in each room and give you an average. If you really want to know what the humidity is, you should be mapping it with your device that you can walk around with and kind of get that and keep track of where you're at, a couple measurements in the room, move around, and then map that. So do not think that one test in the living room is going to tell you everything about the house. This is the number one thing, source control. Exhaust fans, local exhaust fans are going to be massive, and you need to know that they're going outside and that you are measuring them and you are getting hopefully more than 50 CFM out of that. You should be looking for hoping to get 70 or more. And is it appropriate to the amount of size of the bathroom or how much water people are doing? And use your exhaust fans. Sometimes they're tied to the light, which may be good, may not be. People leave, they turn the light off, so does the fan. So think twice about what you're doing for control for your clients. I put this in because I've been around the mold industry. I was a certified mold inspector. I was a CIE in a former life. That's the person who was just under a hygienist to tell you how to fix these issues or what to do about them. And mold is the visible evidence of a moisture problem. And I got frustrated with the industry because the industry just wanted to fix the problem, tear out that drywall, remove all this stuff, and they would leave. I'm like, you didn't fix the moisture problem. The moisture problem is coming because the crawl space has bad drainage and water keeps coming into the house. They're not using their fans in the bathroom. The fan doesn't work. Mold is not the problem. It's the visible evidence of a moisture problem. Please focus on the problem. I'm not saying to ignore the mold. I'm saying that mold is not the problem. It's the evidence of a problem. I'll leave it at that. Ventilation is come of age. We've been preaching it for a long time. Balanced ventilation is now the future of what we're going to be doing. I know some weatherization groups are already doing this. There's a lot of low level, I call them hallway ERVs that you can put in. I know Panasonic just came out with one that I think goes up to 60, maybe even higher. So it actually does the whole source in terms of doing everything you need for ASHRAE. A lot of this is now, in fact, Colorado is headed for their code, their building code, that you will be putting in an ERV or similar. The spot ventilation is fading out for many of these states. So we need to accept how to do that. That's requiring a design that you're taking air out of bad areas like bathrooms and kitchens, and you're then replacing it with outdoor air that's tempered and putting it into areas where you want it to be in, like bedrooms and offices and that kind of stuff. So you have to think ahead about where we're going to do and how we're going to do that. A lot of great thermostats are giving you options to control these things about the house and the ventilation products, and whether or not you need to add dehumidification or humidify, depends on your climate. Is the system sized correctly? Is it running enough to remove the moisture? Oversized systems can short cycle and they're not removing the amount of moisture that it was really intended for. So there's a lot of education and actually design or consideration to determine. Again, we went back to, is your HVAC working well for you? And is it now actually dehumidifying as you needed it to?
Same.
Same again. There we go. Optimize your system. There's a variety of ways to do that. In fact, I'll lean on BPI to maybe we should do one about just evaluating the
Hmm.
HVAC system and how to optimize that as a weatherization contractor or something like that, or how to work with a contractor to do those things. So yeah. Your homeowner is the one who's controlling their own environment is really the bottom line. They may not even be aware that not using their exhaust fan is why they have mold in the ceiling, right? They may not be aware that they're not using their kitchen exhaust fan because it's too loud. That may be causing moisture issues or other VOCs or other particulate issues. So your goal is to explain to them what and why and show them where the issues are and provide documentation and let them really make sure they understand their environment. Can't stress enough about what this is. This is actually an amazing reference guide. Whether you go ahead and pass the exam and become get a certificate or not, man, this guide will many of the questions that we talked about and things you want to know way more about, it's in there. It is a phenomenal resource for anything you want to ask about.
Awesome. Thank
So
you so much, Jay and Joe. Jay, were you going to say something else?
no, the one thing I say is that there were some chat stuff and some stuff in the
Yeah.
Q&A, and we may not get to it today, but I'll coordinate with the group. And worst case, we can provide a response in a day or so about, hey, this was too much to address, and we can provide some answers to everybody.
Absolutely. Sounds good. It looks like most of the questions were answered already. There's a question in the chat right now. Are there resources that you can recommend for sharing IAQ info with homeowners that is easy to understand?
I think there's a variety of resources out there. Off the top of my head, I don't like, oh, go to such and such, but EPA is the number one resource for all of this stuff. Everybody wants to use that as their resource. So I highly encourage you to use the EPA, and they have everything on the EPA is federally funded. I mean, you can use it and hand it out, give it for free, whatever you want to do. That is a free resource for everybody to use.
Yeah, I think, you got to start with what's for what reason. I mean, if you're selling or if you're trying to get their approval so that you can install that piece of equipment, then your equipment manager or manufacturers probably have some sales sheets or some explainers. If you're in a program based thing, then you might want to just explain why you do what you do. Um, and oftentimes there's resources for that, or just sit down and throw a couple bullet points into an AI generator might come up with a really good list of things to say.
Great. We'll take one more question really quickly. How do you determine at which point a higher MERV rating may be having a negative impact on IAQ?
Wait, I'm going to address
Negative.
that. So yeah, no,
Okay.
there's not a negative effect on it. It may have a negative effect on your system, which meaning that your static pressures need to get measured
Right.
for that filter. So that filter may be restrictive, but that doesn't mean it's the filter's problem. It means that your system has got issues. The return is too small, probably, or maybe the supply is too small, or there's a variety of conditions that are making it difficult. So going a MERV 8 is a pretty basic filter. If you have any issues high static with a MERV 8, then you really need to evaluate the system, not the filter. So it's a holistic approach, like everything is. Make sure the system is doing as best it can, and then use the appropriate size filter that you need. Maybe a bigger filter is better. Maybe you need to alter where the filter is located. Maybe I need to add another filter location upstairs or someplace to get more flow in without being restrictive. There's a variety of things that a good contractor can assess with that, but it isn't usually the filter problem. It's actually the design of the system.
Awesome. Thank you. We're going to stop there. If you have any questions, feel free to reach out to Jay and Joe. Hopefully you had a chance to scan the QR code for the Healthy Housing Principles. If not, you can find it on the BPI website under certificates. And then I just wanted to share that we have a survey for feedback. So thank you again, Jay and Joe. We really appreciate it. If you don't mind sharing your feedback to the rest of the individuals that were able to log on, that would be great. We'd love to know what we can do better. And last but not least, if you are here to receive a BPI CEU, please send us an email at ceus@bpi.org and make sure you mention your name and ID number. I will leave that up for a second in case you need to copy that email. I'll actually also toss it into the chat for you. And actually, one more final reminder, we will be having an upcoming webinar that is going to focus on what's new at BPI. So we'll give you more information about certificates, standards, certifications, and much more. So keep an eye out on your emails for the invite. And with that, we appreciate you all attending. Thank you and have a great rest of your day.